maximum and minimum values of y is equal to x squared minus 2x minus 3 squared minus 2 times x squared minus 2x minus 3 plus 1 when x is either greater or equal to 0 or equal or less than 3. So let's think about what is maximum and minimum point in the quadratic function. And all of them are defined by a leading coefficient which we usually notated as a. So the first case is when the a value, which will going to be the leading coefficient of a quadratic function, is greater than 0, which means when the a value is positive, the graph of a quadratic function will go upward, or we can say it opens upward. When the quadratic function's graph goes upward, for example, it will look something like this that keeps going up and never ends or intersects together. It contains a specific one point right over here, which will going to be its minimum point of our quadratic function, which we also call it as lowest point of the graph. So this is the first case where it is defined to make a minimum point of a quadratic function, and it is a case where the leading coefficient is positive value. The second case in the quadratic function is a case where the a, which will going to be our leading coefficient, is less than 0. And when it is less than 0, the graph of the function will go downward unlike the first one. If the graph goes downward, for example, it will look something like this that keeps going toward downward and never intersects at one specific point. But down here we're going to contain a one point, which we call it as maximum point of our quadratic function, and which we usually call it as highest point on the graph. And the highest point of the graph will going to be defined when the leading coefficient is negative value. And if you think about the terms of minimum and the maximum point, so for the vertex of a quadratic function, it is same thing, it is same concept of adding both minimum and the maximum points of the graph's numbered possibilities. And if you add both numbered possibilities, we call it as vertex of a function, or a quadratic function, usually in this case. There is a one more information that they gave us, which will going to be the information about the x terms, where the x is either greater or equal to 0 or less or equal to 3. So at first we need to think about this as the domain and the range of the function, which we learned in the last video, but we review it. So if we review the domain and the range of our quadratic function, this will going to be the third step in order to solve for each question. And at first, let's think about what it is to be the domain of our function. The domain of the function will going to be the range of x values. And the last one, which will going to be our range of our function, our range of the function will going to be the range of our y values. This is what the domain and the range of the quadratic function is. And when we think about the domain and the range of the function, the reason is because the graph of the quadratic function opens either upward or downward forever, and it only contains one point, which we'll call it as vertex But if they gave us the domain or the range of this function, the graph which will opens upward or downward infinitely, we're thinking about it, the limitation of the graph. And we can actually prove it visually through solving this question. Think about our information that they gave us, which were going to be the terms about the x terms. So it will going to be 0, and then x, and then 3. And if you think about this information that they gave us, it's mainly talking about the range of our function when it comes to the x values. So that means this term will going to be the domain of our quadratic function, which will mainly talk about the range of our x values. So at first we need to apply this to our quadratic function. But at first our quadratic function leading coefficient will going to be positive 1, which means the quadratic functions type will go upward, but we don't really care about the graph of this function when it comes to solving for this question, because there is a limitation because of the domain of our function. Of the domain of this function is that for the graph of this function, there will obviously going to be a lot of x values or x coordinates that satisfy its original function, but we are counting it, or we're thinking about the limitations of the graph when it comes to the x value, when the x value is greater than or equal to 0, or less than or equal to -3 or 3, positive 3. So this will going to be our domain of this function. And for the cases, there will going to be total cases of the x value, which will going to be 0, because it includes 0, 1, 2, 3, because it includes 3 also. So there will going to be for a total 4 cases of our x values. So all you have to do is we need to input our quadratic functions limitation x values to our original functions and find the minimum and maximum point. And for the minimum point and the maximum point, if we remind ourselves again, minimum point will going to be the lowest point of the quadratic function, and for the maximum point, it will going to be the highest point on the quadratic function. So first of all, let's think about the case when x is equal to 0. When x is equal to 0, our quadratic function will turn into, let's write our function down, y is equal to x squared minus 2x minus 3 squared, and then minus 2 times x squared minus 2x minus 3, and then plus 1. So if we input 0 to our x values, they'll all turn to 0, and the only thing that it will gonna leave will going to be -3 squared. So if you write that down a little bit smaller, -3 squared minus 2 times -3, and then plus 1. So -3 squared will turn to 9 minus 2 times minus 3 will turn into positive 6. So plus 9 will going to be plus 15, and the plus 1 will turn into positive 16. So our positive 16 will going to be the answer of our output when x is equal to 0. So let's think about the second case where the x is equal to 1. When x is equal to 1, our quadratic function will going to be it is the same thing with inputting 1 to our all x values, which will going to be 1 squared minus 2 minus 3 squared minus 2 times 1 squared minus 2 minus 3, and then plus 1. So if we simplify our terms, 1 squared minus 2 minus 3 will turn into negative 5 plus 1 will to negative 14. Negative 4. Square will turn into 16, and then minus 2 times 1 squared minus 2 minus 3. 1 squared minus 2 and then minus 3 will turn into negative 4. But then we still have times negative 2, which will turn into, so this will turn into negative 4 squared times 2 will turn into positive 8, but we still have our leftover, which we need to also count it, which will going to be 1. So this whole terms will turn into 25. And let's think about the third cases where the x value is equal to 2. So when x is equal to 2, our quadratic function will gonna be same thing with inputting x values into 2, which will going to be 2 squared minus 4 minus 3 squared minus 2 times 2 squared minus 4 minus 3 plus 1. If you calculate it, we're going to give us positive 16, which will going to be the same output of our function with when the x is equal to 0. So for our last case where the x is equal to 3, we know that it can be either minimum or the maximum point, because it is the furthest, is the thing that is located for the furthest from our domain of our quadratic function. So we can actually calculate it. Our first is when x is equal to 3. So when x is equal to 3, same thing with inputting every values into 3 from our replacing x. So we'll turn into 3 squared minus 6 minus 3. We have squared, and then minus 2 times 3 squared minus 6 minus 3. And we still have plus 1. So if you simplify this, 3 squared will turn into 9 minus 6 minus 3 will turn to 9. Even though we square the 0, it will turn into 9. It will turn to 0. We still have negative 2 times 3 squared is 9 minus 9. We still have 1. Even though we're multiplying our square from the terms that its output is equal to 0, they're always going to turn into 0. Which means our output of our function will going to be positive 1, which will going to be the constant without any variables. And if you don't know the definition of a constant means it is a number without any variable. That is what the constant means. So we can figure out that when the x value is equal to 3, our output of our function will turn into 1. So our maximum point of our quadratic function, which is same thing with the highest one, will turn into 25 when x is equal to 1. So we can write 25. And for the minimum value, we'll turn into the case when the x value is equal to 3, which will turn into positive 1. And this will going to be the answer of our question.